SolidWorks flow simulation takes the complexity out of computational fluid dynamics. You can quickly and easily simulate fluid flow, heat transfer, and fluid forces that are critical to the success of your design. Today, we will cover the new functionality of the new release SolidWorks Flow Simulation 2012. For those of you that may be new to SolidWorks Flow Simulation, this slide gives a very quick and high-level overview. SolidWorks Flow Simulation software is a powerful computational fluid dynamics tool that enables designers to quickly and easily simulate fluid flow, heat transfer, and fluid forces that are critical to the success of the design. SolidWorks Flow Simulation is fully embedded inside SolidWorks 3D CAD software, so you can use all the benefits of a fluid flow simulation to design your products with better insight. Design variations can be compared to make better decisions, resulting in product with superior performance. You can, for example, simulate the water flow inside a valve to dimension it with pressure drop, velocity, turbulences. You can test the airflow inside an electronic enclosure to optimize the cooling process, or check the airflow around vehicles among a broad range of applications. Concurrent engineering helps detect design issues early in the design cycle and helps compare design scenarios before going further in the design process. With SolidWorks Flow Simulation and a wide range of technical capabilities that you can see on this slide, you can gain an understanding of the impact of flow on a design before it is built. SolidWorks continues to raise the bar on performance and quality in 2012. Significant time and effort has been spent on improving performance in key areas. This impacts every user, so it has a high priority in our development efforts. Performance improvements in SolidWorks Flow Simulation 2012, providing faster and more accurate solutions along with better usage of multiple CPU cores, enable tasks to be completed better and faster. SolidWorks Flow Simulation 2012 is enriched with enhanced meshing technology, which improves the CAD geometry representation by the computational mesh. As a result, the accuracy of calculation is improved with fewer number of cells. This means, for the users, an improvement of the accuracy of the solution with less cells required to capture geometry, meaning less time to solve it. How does this enhanced meshing technology work? This advanced geometry resolution technology uses points on real CAD edge, here points C1 and C2, to build two faces, A1C1 C2 A2 and B1C1 C2 B2, which correspond to two new CAD faces. With the enhanced meshing technology, the CAD geometry is better captured for a better accuracy with less local mesh refinement. SolidWorks Flow Simulation 2012 offers improvement in multi-core performance. Multiple CPUs have an influence on solution time. To select how many CPUs to use for a simulation, users just need to open the Run dialog box and make a selection in the Use CPUs list. With 2012 release, SolidWorks Flow Simulation better support additional CPUs from 3, as you can see on this slide. The scalability ratio is the ratio between the solution time divided by the number of cells in 2011 and the same value for 2012. It is a ratio of computational time normalized to the number of cells because due to the new meshing technology in 2012 is different than in 2011. SolidWorks Flow Simulation offers a wide range of physical models and fluid flow capabilities so designers can obtain better insight into product behavior for a broad range of applications. SolidWorks Flow Simulation 2012 is enriched with new physical models to leverage even further the usage of CFD during design process. In a fluid thermal analysis, contacts between components need to be taken into account for a proper heat transfer simulation. The new thermal joint helps you simulate the heat transfer from one phase to another by specifying thermal resistance. You can transfer heat from one phase or assembly of phases to another phase of assembly of phases without modeling the conductor itself. Users then do not need anymore to resolve the legs by the mesh, which means less cell and then less solution time. It helps to simplify models and then reduce the mesh complexity, providing faster calculation without loss of inaccuracy. Users can then test product early in the design process faster than ever. Available in the HVAC design module, the new tracer feature gives you the possibility to quickly simulate concentration source, surface condensation, or evaporation from an admixture fluid, for example, water vapor or toxic gas, in the carrier fluid, for example, the air, under the assumption that the presence of the admixture had negligible influence on the carrier fluid flow. The tracer can be used to quickly and easily track the concentration distribution of a gaseous component within a domain. For example, to see how the smoke is distributed from various smokers in a restaurant. You can then simulate concentration source very quickly during the design process, running what-if scenario in SolidWorks Flow Simulation 2012. Let's take a look inside this chemistry lab to see how a fire or an exothermic reaction affects the air quality of the room. The new tracer study can quickly be set up with this easy-to-use step-by-step wizard. Most of the usual tracers such as CO, NO2 and HA3 are available. You can also create them manually through the engineering database. After the gas contaminant, the emission rate, and the initial condition are defined, you can run the study. In addition, since this is a post-processing calculation, you can simulate many different scenarios without having to rerun the whole study every time. Once the calculation is done, you can then visualize the airflow and the contaminant concentration profiles. You can also easily see the path of carbon monoxide with a new parameter automatically added to the list. In this configuration, with only one ventilation outlet, you can see that a pocket of gas is being retained just under the ceiling due to the heat released. Using tracer study, it is also incredibly fast and simple to investigate the impact of a design change made to the ventilation system. In this particular scenario, installing a second outlet will dramatically reduce the concentration of carbon monoxide by a factor of 4. The HVAC module of SolidWorks Flow Simulation enables engineers to access to the thermal comfort parameters during the design process. What is thermal comfort? It is designed in the ISO 7730 standard as being that condition of mind which expresses satisfaction with the thermal environment. However, thermal comfort is a subjective sensation. So the realistic aim is to create a thermal environment which satisfies the maximum possible percentage of people in a given room, taken as a group. Assessment of the thermal environment in the occupied zone requires to know what is called a comfort parameter, such as PMV for predictive mean vote and PPD from predicted percent dissatisfied indexes. In addition, draughts are the most common complaint when talking about indoor climate in air conditioning, building, vehicle, or airplane. SolidWorks Flow Simulation 2012 is offering a new comfort parameter in the HVAC module, the Draught rate, which represents a percentage of people discomforted by Draught. This new parameter increases ability to evaluate environmental comfort for workers and quickly see the impact of changes to air conditioning system. SolidWorks Flow Simulation 2012 SP1 offers an improved solution adaptive meshing technology. A solution adaptive meshing is a procedure for adapting the computational mesh to the solution during the calculation. It splits the mesh cells in the high gradient flow regions for a better accuracy of the solution. This new method considers each gradient area separately for a better refinement strategy. This new method creates a more uniform mesh without holes and abrupt junctions, which is good for the solver and leads to a better accuracy. The new solution adaptive meshing method decides whether to split a cell or not based on each flow parameter's derivative separately, based on many indicators such as temperature gradient, concentration gradient, etc. With the new solution adaptive meshing method, we are removing the need of complex definition of refinement criteria to be defined and then simplify the meshing step. The improved refinement technology drastically improved the quality of the computational mesh in the high gradient flow region. This minimizes approximation errors by creating more uniform mesh without local holes and layers of uniform size cells. For the comparison between SolidWorks Flow Simulation 2012 SP0 and 2012 SP1, the aircraft model called DLR-F6 has been used. It is a model used as benchmark model for drag calculation. You can see the mesh in SolidWorks Flow Simulation 2012 SP0 and 2012 SP1 on that slide. The holes and sharp changes do not exist anymore for SP1 mesh, giving a better uniform mesh and then a better accuracy for the CFD analysis. This new method provides a better accuracy as shown in this slide, which compares the drag result between experimental data in light blue, SolidWorks Flow Simulation 2011 in light red, and SolidWorks Flow Simulation 2012 SP1 in light green. Accuracy is improved with that new solution adaptive meshing technology. A fan is a type of flow boundary condition considered as an ideal device creating a volume or mass flow rate depending on the difference between inlet and outlet pressures averaged over the selected phase. SolidWorks Flow Simulation 2012 SP2 offers an improved fan model for a more accurate and more robust simulation of the fans, mainly for simulation when you have several fans installed. How does this work? On every outer iteration, so time step, we solve simultaneously for pressure correction over a whole domain and mass flow through the fan, thus forming an extending nonlinear system of equations. As a result, mass conservation is ensured simultaneously with fan curve satisfaction. The main advantage of the new fan technology is that we are on fan curve as every iteration. This leads to a better conversion simulation for multiple fans. So let's review some examples of convergence plots for simulation with fan to compare them between SP1 and SP2. So SP2 using the new fan model. Here is the SolidWorks Flow Simulation tutorial of the electronic enclosure assembly. This model contains only one fan, but you can see that the first iterations are smoother with the new fan model. Here is a customer example from our technical support group. The new fan model offers a better convergence, as you can see on the right side of the slide. The last example is a QA model with 3 internal fans. This might be an extreme example with 3 fans pretty close to each other, but this shows well the improvement in conversion with the new fan model. The new fan model is very powerful for such multiple fan simulations. Every release, SolidWorks strives to deliver a rich customer experience. SolidWorks Flow Simulation 2012 takes a deep look at those things you do repetitively, days in and days out. This has been a priority for this flow release. Sometimes consider the unsung heroes. Simple improvement in usability tools are the thing that creates a unique, easy-to-use experience you have come to expect over the years. If you are solving a problem that uses the heat conduction in solids option, you can specify the thermal contact resistance at the solid-solid and the solid-fluid boundaries. Thermal contact resistance can be specified either by inputting the value of thermal contact resistance or by inputting the thickness and material of the contact layer. In SolidWorks Flow Simulation 2012, the contact resistance might be specified on faces or parts of faces at the solid-solid interface only. The Apply to Solid-Solid Only option in the contact resistance dialog box allows you to enable contact resistance only at overlapping parts of solid surfaces in contact. This will save you time by detecting the surface of contact, and so you don't need to split the faces anymore. SolidWorks flow simulation with the electronic cooling module is able to calculate steady-state direct electric current in electroconductive solids. In presence of the electric current, the corresponding specific joule heat is released and included in heat transfer calculation. When solving a problem that includes electric current, user can specify the electrical contact condition at the boundary between two conducting solids or on the outer boundary of a conductive solid. With the new release N12, the specified electrical resistance is applied to real areas of contacts between conductive solids without the need to create split line anymore. SolidWorks flow simulation divides the model into solid and fluid regions for the CFD analysis. The Check Geometry tool allows users to check the bodies for possible geometry problems that cause flow simulation to create an inadequate mesh. In the invalid contact box, users see the list of the detected invalid contacts, if any. Invalid contacts may be selected by clicking on their name in the invalid contacts box. To improve usability, SolidWorks Flow Simulation N12 adds callouts to identify easily the invalid contact location in the graphic areas so you can fix them quicker. In the post-processing tools, the parameter list allows users to select result type that you want to display while viewing results. In SolidWorks Flow Simulation N12, the interface of the parameter list dialog was redesigned to provide you more flexibility when selecting parameters that you want to display while viewing results. You can sort them by name, group, or unit. Color bar is a color stripe which displays the scale of parameter values in respect to contour color. Several usability improvements have been implemented for the color bar for the post-processing task. You can now dynamically adjust the palette size, position, and numbers of level of the color bar. You can define now the default settings and appearance of the color bar under the General option. The color bar dialog box now contains a range of new palettes optimized for visualization of the temperature distribution. These enhancements offer to the user a more precise control over result plot layouts and visualization to meet his needs. User can quickly get access to the result he needs for his product performance test. The ultimate objective of a CFD simulation is to get valuable information so users can easily compare design alternatives and choose the best one for performance and quality. When dealing with multiple plots or trajectories to review key results on different locations, the new high-quality highlight tool helps users to distinguish contour of different parameters in one plot. This is available for indicating the selected plots or trajectories. The new post-processing options really help you to further understand what's going on in the system, more immediately and accurately than ever before. You can now dynamically adjust the position of the palette, the size, and the number of levels of color to improve the clarity of the results. You can also modify the appearance and define a maximum number of values displayed. But more importantly, you can edit the color bar and change the palette used to optimize, for example, the visualization of temperature distribution. The new high-quality highlight also helps you to quickly distinguish between plot images, especially when working with multiple results on the screen. Finally, a new crop region option enables you to specify a 3D box that crops the flow trajectories area. So it is a lot easier and faster to focus on a particular part of your study. Additional enhancements have been added to the post-processing tools to enhance the ease of use of SolidWorks flow simulation. In a single click, you can now export multiple surface parameters to Microsoft Excel. In SolidWorks Flow Simulation N12, you can now record screen activities as an animation file. Also, this feature allows you to record context animating plots. This is very useful to create video of a CFD result for internal or external communication. The interface of the Save Image and Save As dialogues was redesigned to a new style, more flexible and easy to use. You can now define the size and orientation as well as the image type in a single dialog box. The flow trajectories result type allows the user to display flow trajectories as flow streamlines. This great post-processing tool helps users to visualize how the fluid is circulating inside or around the product design. In SolidWorks Flow Simulation Zone 12, users can define a 3D box that crops the flow trajectories area. This option is very helpful for large models to focus on their region of interest. SolidWorks Flow Simulation contains built-in criteria to stop the solution process. Users can use customized criteria named goals, which are physical parameters of interest in the project. Goal convergence is one of the conditions for finishing the calculation. They can be defined as global goals, surface goals, volume goals, as well as point goals. In SolidWorks Flow Simulation Zone 12, an additional point selection mode is available for point goal definition. No user can select desired points by picking their position from the screen. The point goal tool is now consistent with the points parameters. In SolidWorks Flow Simulation Zone 12, material properties exchange is easier than ever, with the capability to both export and import material property through an XML file. A third example has been added to the HVAC module tutorial in 2012 release. This tutorial considers a urban pollution in a street canyon and demonstrates how to use a new tracer study to simulate the pollutant dispersion. A new language is now available in SolidWorks Flow Simulation 2012. Simplified Chinese user interface and online help are now available. SolidWorks Flow Simulation 2012 represents a strong new release focused on performance and user experience. From simple time-saving shortcuts to improve performance and quality and new physical models, SolidWorks Flow Simulation 2012 has great enhancements which will help users embedding CFD simulation in their product development cycle better than ever. We hope you will be pleased with the result. Thank you.